Good morning, children. I welcome you all to today's session of mathematics, and we are on to geometry. Right? Geometry is all about figures, you all know, right? And in class 4th, we had learned about tangrams, tessellations, and symmetry. We had also studied about circles and how to draw them. Now we shall learn more concepts of geometry, right? We should be going forward towards more concepts of geometry. And the first is angles, right? An angle is made up of two rays starting from a common end point, right? This is super duper important, that what is an angle. It is made, it has to be having two rays. See, this is OA is one ray and OB is the other one, right? That also means there should be 3 points. See, in this figure there are 3 points, O, A and B. So these are the 3 points that constitute an angle, right? An angle leads to three division of a region, right? The region is divided into three parts. See here, right? On the angle, the interior on the angle, the interior of the angle and the exterior of the angle. These are the three. The inside part of the angle is called the interior of an angle, right? This one, see here, this is the interior of the angle and this one is the exterior of the angle, right? Outside. Okay, see here, interior and exterior. The angle is measured by protractor, which is like this. It's there in your geometry box. If you will open it, you will find this instrument there. Now place the center of the protractor on the vertex B. This is the center, see children, here. And this is the vertex. Right? This is the line which needs to be put on the vertex of angle ABC. Vertex, after the adjust the protractor so that the baseline falls along the arm BA of angle ABC. See that 0 of the inner scale is on the arm BA. Read the mark on the inner scale when the other arm BC of the angle crosses it, right? So, and then read the mark on the inner scale when the other arm BC of the angle crosses it. See, this is how you need to do it. It is 55 degrees, so measure angle 55 degrees here. Angle ABC is 55 degrees. This angle, see children, this one, and this is how you need to do it. This is of 55 degrees. Note the angle was drawn on an anti-clockwise sense, right? Angle is always drawn in an anti-clockwise sense. Place the center of the protractor on the vertex E of angle DEF. Observe that opening of the angle is to the left. Adjust the protractor so that the baseline falls along the arm ED of angle DEF. See that 0 of the outer scale is on the arm ED. Read the mark of the outer scale when the other arm EF of the angle crosses it. It's 110 degrees. See, this angle will be 110 degrees. Right? Now, any two angles can be compared like this. See, we have just measured angle 55 and 110 and 55 degrees less than 110. Therefore, angle ABC is less than angle DEF, or angle DEF is greater than angle ABC, or DEF is equal to twice of ABC. Now, an angle whose measure is greater than the measure of another angle is the greater angle. Also, if two angles have equal measures, and they are said to be congruent. Right? Now here, how to draw an angle is there, just as previous. Now kinds of angle. There are three kinds of angle: acute, right angle, and obtuse. Acute angle is the one where when the angle is measured, it is found to be less than 90 degree. Remember, acute angle, the angle should be between 0 and 90 degree. It's called an acute. 90 degree is called right angle, and 90 and 180 is called obtuse. That is, if the angle is less than 90, acute, 90-degree right angle, and more than 90 is obtuse angle. Right? See here, in this you need to do this exercise, right? The second one, see the angles whose measure are given: acute, right, obtuse, and straight. See the first one, 43 degree, it is less than 90, so this one is acute, right? This is acute. B 137 degree. It's more than 90. It's obtuse. C 185 degree. Right? 185. It is more than 180. So this will be a reflex angle. This one is reflex, REF, right? And this is how you need to do this exercise. Now we come to straight away to symmetry. A figure is said to have line symmetry if folding the figure along a line, the left and right patterns of it coincide exactly. The line is called the line of symmetry, as can see the figure. If we fold this one from this line, you will find two equal halves are there. In our hand, there is no such line of symmetry because the thumb is entirely different from this finger. Right? A figure may have no line of symmetry, one line of symmetry, two, three, and so on. Line of symmetry can be observed in English alphabet in the uppercase. See B, C, D, E, K. They have one line of symmetry. Right? These have horizontal lines of symmetry. See, this is horizontal. And here in the next set there is vertical lines of symmetry. Right? A, M, T, U, V, W, Y. There are 7 letters. And there are some in which there are horizontal as well as vertical lines of symmetry. Both lines of symmetries are there. And these are HIOX, right? See in H, horizontal as well as vertical, both are there. O, X. Letters F, G, L, there are some letters who have shown no lines of symmetry. In digits also, there is a horizontal line of symmetry. Horizontal plus vertical both is there in O, horizontal is there in E, horizontal plus vertical is there in 8, right? 3 has one line, only one, 0 and 8 have two lines of symmetry, and less don't have any. Triangles may or may not show any line of symmetry. Isosceles triangle has one line of symmetry. This is very important. So that simply because the base angles may be equal, right? In isosceles, generally you find that two angles are equal. An equilateral triangle has three lines of symmetry. See here, because all the three angles are equal, so it can be divided in any way. Right? A kite has one line of symmetry. A straight rectangle has two lines of symmetry. Square has four lines of symmetry. Now let us try to find what is line of symmetry. See how to draw it. Now this can be divided by this, like this, into two halves. Also like this into two halves. Also like this square. And also like this. So it is having four lines of symmetry. Right? Okay. Now in this exercise you need to draw lines of symmetry. Right? You all know in A there is only one vertical line of symmetry. Right? So straight away we will be cutting it into two. Sorry, not like this. Definitely not like this. Okay, like so. So use scale here to cut it. Right? And then there are others diagrams. See, you have to judge whether there is line of symmetry here. In 7, see in 7 this structure is entirely different to this, so no line of symmetry. In W we have one line of symmetry, right? Now reflection, this reflection symmetry, right? So this is reflection, this is the mirror image of anything. Mirror reflection leads to symmetry but with left and right discrepancies. This is the type of symmetry in which one half of the object is the mirror image or reflection of the other half. Now here you have to draw the mirror image, right? Now how you need to draw is, see, outer components are the same. See here also we will be writing R here. An inverse R we will be writing. Then this will look like this. And then from here we will be drawing like this, right? This is how R will look. Rotational symmetry. Rotational symmetry is when an object turns an object about a fixed point is known as center of rotation. 90 degrees called quarter rotation. Rotation of 180 degrees called half rotation. Rotation by 270 is called three-quarter rotation. And rotation by 360 is called complete rotation. See here, when we rotate this figure, it looks exactly the same. Right? So this is about rotational symmetry. Now we need to do this. Now see, this is complete the table. Right here it shows, first figure it shows all the rotations, right? It shows all the rotations, right? Then this second one, see, in the second one, if we make half the rotation, quarter rotation, nothing will occur, right? Half the rotation also it won't be symmetry, right? Sorry, half the rotation, this, there will be symmetry, because this the sides will change, right? And half the rotation, this end will come here and this end will go up, so it will show half and full, it will show symmetry, right? And this is how we need to do this exercise. So we come to the end of this chapter with this. I hope you liked it as much I did in making it, and until we meet again, it's a goodbye.